Chapter 7. This is the algebra chapter. Sections 7.1 and 7.2 are going to provide some background information. Algebraic language and formulas. The arithmetic symbols have the same meaning in algebra with the exception of the multiplication symbol. Since the algebraic x looks like the multiplication symbol, there are different ways to show multiplication in algebra. With a dot, as in a dot b, with parentheses, a parentheses b, or parentheses a parentheses b, or with nothing at all, just a b. One of the most useful and important skills in technical work is being able to find the value of an algebraic expression when the letters are given numerical values. A formula is a rule for calculating the numerical value of one quantity from the values of the other quantities. An example of the formula is Ohm's law. Ohm's law says that the voltage V in volts across a simple resistor is equal to the product of the current I in amperes through the resistor and the value of its resistance R in ohms. We write Ohm's law formula as V equals IR. To evaluate a formula or algebraic expression means to find its value by substituting the numbers for the letters in the expression or formula. The steps you follow to do this are place the numbers being substituted in parentheses, then substitute them into the formula. Do the arithmetic after the numbers are substituted. Don't forget to use the correct order of operations according to PEMDAS. Here's an example. The following formula is used to calculate the number of joists, J, needed to cover a distance L when spaced 16 inches on center. You're given the formula J equals 3/4 L plus 1, and you're given that L is 44 feet. Turn off the video, try it yourself, and we'll go over the answer on the next slide. So the formula, J equals 3/4 L plus 1, and you're given that L is 44 feet. So you're going to substitute 44 for L in the formula and solve it. So you're going to write it first, J equals 3/4, substituting 44 for L in parentheses, plus 1, equals 34 joists. So remember that the parentheses means to multiply, so you're going to multiply 3/4 times 44 and then add 1. Adding and subtracting algebraic expressions. So to simplify algebraic expressions, it's necessary to know how to add and subtract the algebraic terms in the expressions. We do this by adding and subtracting like terms. Two algebraic terms are said to be like terms if they contain exactly the same literal or letter part. So 2x and 5x are like terms because the literal part, x, is the same for both terms. The number that multiplies the letters is called the numerical coefficient of the term. The two terms, 3xy squared and 7xy squared, first of all, are like terms because the literal part, xy squared, is identical. The 3 and the 7 are the numerical coefficients of each of those terms. Some examples, 2x and 3x squared are unlike terms because their literal parts are not identical. One has a literal part x, the other has a literal part x squared. You can add and subtract like terms, but you cannot add and subtract unlike terms. If a term doesn't have a numerical coefficient in front of it, then the coefficient is assumed to be 1. The term x is the same as 1x, but you don't need to include the 1 when using it in an algebraic expression or answer. Try these examples. The answers are on the next slide. Add 2x plus 3x. These are like terms because their literal part x is the same, so you can add the coefficients. 2x plus 3x equals 5x. Now, subtract 8a squared x minus 3a squared x. These are also like terms because their literal parts, a squared x, are exactly the same, so you can simply subtract the coefficients. 8a squared x minus 3a squared x equals 5a squared x. Now solve 8 x squared plus 2xy minus 2x squared. We cannot combine the x squared term with the xy term. Those are unlike terms because the literal part is not the same. xy is not the same as x squared. But we can combine the 2x squared terms. So the equation becomes 8x squared plus 2xy minus 2x equals 8x squared minus 2x squared plus 2xy. We can subtract the coefficients on the like terms, 8x squared minus 2x squared, and then leave the 2xy term alone. So the answer is 6xy squared plus 2xy. Expressions with parentheses. Parentheses are used in algebra to group together terms that are to be treated as a unit. There are three main rules for removing parentheses. Rule 1, if the parenthesis has a plus sign in front, just remove the parentheses and solve the equation. Rule 2, if the parentheses has a negative sign in front, change the sign of all the terms in the parentheses, then remove the parentheses and solve the equation. And rule 3, if the parentheses has a multiplier in front, multiply every term in the parentheses by the multiplier. This is the most common error that I see when solving algebraic equations, is to forget to multiply every term in the parentheses by the multiplier. So here are some examples. Rule 1, 2x plus 3x plus 4 in parentheses. There's a plus sign in front of the parentheses, so all you have to do is remove the parentheses and solve the problem. Now it becomes 2x plus 3x plus 4. The like terms are 2x and 3x, so we add the coefficients, 5x plus 4. Rule 2, a minus, in parentheses, 2x minus y. Now there's a negative sign in front of the parentheses. So you have to change the signs of all the terms in the parentheses before you remove them. The equation becomes a minus 2x plus y. And that's the final answer since there are no like terms in the expression. Notice 2x is positive inside the parenthesis and we changed it to a negative when we applied the negative outside of the parenthesis before we removed the parentheses. Rule 3, 2 times a plus b in parentheses. Remember, we have to multiply everything in the parentheses by 2. So it becomes 2a plus 2b. In this case, the 2 is positive, so it doesn't change any of the signs of the terms in the parentheses. But for this expression, negative 2 times a plus b in parentheses, since the 2 is negative, we're going to multiply a by negative 2 and b by negative 2. And remember the rule, when you multiply a negative and a positive, the answer is negative. So this becomes negative 2a minus 2b.